Hello! Today we are going to be working on the first objective of geometry, which is to simplify radical expressions. So radical is another name for root or square root. So what we're going to be doing is taking square root of 90 and turning it into something that's simpler, meaning we're going to break down the number itself and find any perfect squares that are inside of it. So the way we do that, we start by doing a factor tree, which you probably remember. You break this down as far as you can in every direction. So when I look at 90, I say, okay, that's 9 times 10, and then 9 breaks down farther into 3 times 3, and 10 breaks down farther into 5 times 2. And you notice the end of every branch is what you're looking for. So these are the prime factorization of 90. So another way to, the reason we do this is that another way to write square root of 90 would be the square root of 3 times 3 times 5 times 2. Because all of these numbers, when multiplied together, give you 90. So, what we now do is we look for pairs. 3 times 3 is 3 squared, and the square root of 3 squared is just 3. So whenever you have a pair, it goes to the outside of the square root as a single number. So 3 is now on the outside, and on the inside, you still have 5 times 2, because neither of those have a pair. So our final answer here is going to be 3 square root of 10. And to check your answer, you can type square root of 90 into the calculator, and when you do, you get 9.49 approximately. And you type this into the calculator, 3 square root 10, and you also get 9.49. So these are equivalent radical expressions, but this is simpler because the numbers are smaller and there's fewer factors inside the square root. So let's try this again. Next example has a 4 out front. There's really not much different about that except that that 4 is just hanging around. The first example had a 1 out front. We just didn't really need to think about it. So we will still look at 75 and break it down. You can break it down however you want. I see 3 times 25, and then 25 keeps breaking down into 5 times 5, and those are the ends of the branches. Those are all the prime factorization. So what we have here, we have 4 times the square root of 3 times 5 times 5. Now again, we now look for doubles, which is the 2 5s, and doubles on the inside become a single version of that on the outside. So on the outside there was already a 4, now there's a 4 and a 5, and the only thing left on the inside was that 3 right there. So our final answer here, when we simplify all this, is 20 times square root of 3. Our last example is 10 square root of 180. We're just going to do this one more time. So 180, break it down however you want. I'm going to say that this is 20 times 9, and then 20 breaks down into 5 times 4, and then 9 breaks down into 3 times 3, and 4 also breaks down into 2 times 2, and I think that's it. These are all prime numbers. So what we have here is 10 times the square root of 5 times 2 times 2 times 3 times 3. Kind of running out of space here. And you notice what's different about this one is that we have 2 pairs. We have a pair of 2s and we have a pair of 3s. So there's nothing different about how it works though. So each pair sends a single number to the outside. So I'm going to go a little bit farther down so you can see it. We're going to have an extra 2 on the outside and a 3 on the outside, in addition to the 10 that was already there. So outside of the square root, we have 10 times 2 times 3. And the only thing left inside is that 5 right there. It had no pair with it. So 10 times 2 times 3 is 60. And square root of 5 is just square root of 5. So that is it. So our objective today was that we have now simplified radical expressions.